There we go. Oh, plenty of people, plenty of people waiting there in the waiting room, which is great. Great to see people eager and ready to go. Let's have a little look at our participants here, which is great. Oh, you see a few familiar names in there, which is spot on. Thank you so much, everybody, for tuning in to our webinar on this lovely Wednesday evening. Just to introduce myself, so my name's Lucy. You'll probably know me as DevHub Community Manager, and along with me here I have Sophie, who is part of my team here, helping me do promotions and running DevHub overall. So just while people are coming in, I'll just give everybody just a second there. Sam, how have you been? How's your day been going? Been enjoying the sun?
Yeah, I mean, as much as you can, trapped inside a little box in front of a computer all day. But no, it's been good. Managed to get out at lunch. Didn't quite go running because I'm not a madman in this heat. But yeah, no, it's been good. Been good.
I don't blame you. We're quite lucky here at our office. We managed to sunbathe out. We've got a south-facing car park, so we pulled the bean bags out. So we've been sunbathing today, which is great. Get to enjoy a little bit of sun.
Super. It's amazing you get any work done, to be honest. That's dangerous.
But yeah, I can still see a few people coming in, but we'll just pretty much get started. Just to give everybody a little bit of a heads up, so we've got the chat box down the bottom. Yes, this is getting recorded as well. Yeah, you can use the chat box if you want to put in any sort of introduce yourself or whatever. We've also got the Q&A chat as well. So throughout this presentation, if you do have any questions for Sam, feel free to put them in there and he'll answer them at the end. So if you think of anything as you're going through, just pop them in there. And Sam will get round to them. So it's a pleasure having you here, Sam. Thank you so much for teaming up with DevHub North. So a little introduction. So Sam is a senior software engineer, and this is his chosen topic that he's going to sort of give you all the information on. So yeah, I'll let you sort of take it away, Sam.
Super. First and foremost, everyone see the screen all right? All good? We're good to go. Beautiful. You should be able to see some slides, hopefully, one would hope. Yeah, all good. Silence is golden. All right, hello. Yep, so my name's Sam Edwards. I am a senior software engineer based out in Leeds. And yeah, I just wanted to do a talk. It's been a topic that I've wanted to talk on for a really long time. And I think it's a topic which it's not the first thing you learn when you start as a developer. And it's certainly not the second first thing you learn. So I wanted it to kind of, I thought it'd be a really good intro to people that have never heard of the concept of performance testing before. And that's what we're going to talk about today. Okay, so yeah, as I say, my name's Sam. So yeah, I'm not the handsome chap on the right. I'm the goofy looking one on the left. But yeah, I've just put my socials at the bottom there. So if there's any questions I can't answer today, which is probable, or if there's anything else you want to reach out about and just have a chat, you can put them in the Q&A in the chat or just reach out on any of those links. So yeah, what do I like? Love running, history and pipelines. What do I dislike? Completely unavoidable production outages, and I'm sure I'm not the only one. Okay, so I just wanted to start with a really brief kind of description of what performance testing actually is. I think people have heard it kind of battered around a lot of the time, but they've never actually used it in anger. And it's such an important thing that we need to kind of get to grips with and learn about. And I think should be introduced earlier on when we're learning as developers. So yeah, what is it and why do we need it? Cool, so this is a completely hypothetical situation, a completely fake company, but I just wanted to give you an idea of where performance testing might come in useful. So imagine you're a developer at a company, you've just set your kind of site ready to go, it's ready to launch. You wake up on the day and you press that big red button and you say, right, let's go, we're ready to go to prod. So all the marketing goes out, you've pushed it all out, and you know, you're really happy that you finally pressed that button. You get really excited. This is the traffic at the bottom here. You can see if your site users are starting to trickle in. Everything looks good. So, you know, you get a congratulatory email from your CEO at 10. All systems look green. You're starting to think about what you're going to do with that lovely bonus. And you even treat yourself to a pub lunch. So you say, as users start trickling into your site, we've reached the top page of r/damn, that's interesting, amazing, fantastic. You start thinking about, right, I could definitely think I could work at Amazon now. I've reached it, I'm in my peak. Oh, but don't celebrate too soon, because as the traffic ramps up even more, your product owner calls you and says, oh, the call center, we've got a lot of calls from the call center and things seem to be going wrong, but we can't quite work out what's going on. People can't sign up, they can't sign in, they can't do whatever. You rush back to the office and you see that the support engineers are reporting thousands of errors. It's really difficult to see what the issues are, and they're all over the place. You can't quite tell, you can't see the wood for the trees. You glance at Twitter and it seems to be full of confusion. People can't log on, others can log on, but they don't get their order confirmation. So no one really knows what's going on and why this isn't functioning as expected. You spend the most of the afternoon kind of struggling to try and work out how to get this site back up. SRE's struggling, they've ramped up all the resources, but nothing seems to be working. As kind of night draws to a close and the traffic starts to taper off, you think, thank God that's over. I've got the whole of the rest of the next day to kind of fix this damage before users start to ramp up again. But not quite. It's not quite as clear cut as that. Just because the traffic has ebbed away, you might still have issues with, say, that you posted to a backend to send an order and that hadn't actually made its way through. And you actually find that people a couple of weeks down the line haven't received anything from you, and you actually suffer reputational damage, which translates into pennies and pounds, as I think we all know. So hopefully that gives you a bit of an idea of what happens when a launch goes wrong, especially when you're under kind of sustained load for a period of time. So what went wrong? So when you're doing software development, you have two main sorts of testing. You have functional testing and non-functional testing. So functional testing is what the system should do. So how do you use your site? You know, even if it can be manual or automated. I go in, I click about, I can check out, I can do stuff. Fantastic. Non-functional testing, by comparison, is a lot more difficult to see. So it's how the system should behave. So how does it perform under load? How does it scale? Is it secure? Are your databases protected adequately? So functional testing, easy to specify, tested first, rarely forgotten. Hard to specify non-functional tests, they're tested last, and often they're frequently forgotten or never thought about at all. So what is performance testing? So to give it a loose definition, it's a form of software testing that focuses on how a system performs under a particular load. So throw a bunch of requests at something and see how it handles it. It's the really TLDR of that. So what I've got on screen is kind of a normal pipeline that you might have, a really simplified pipeline of an application where you don't have any performance testing baked in. So you might push some code to GitHub, you run some unit tests against it, some lints, you build your app, you deploy it into an integration environment, and then you might run some automated or manual functional tests against that to make sure it's all working. Great, we're going to push that to prod fab. However, when you start to put performance testing into the mix, you have to think about like kind of dedicated environments where you're able to deploy your code in the same way as before, but now there's an extra step where we're going to deploy that code into a pre-production or kind of a performance testing environment. And the idea is there that that's scaled equivalent to your production environment, so it's got the same amount of CPU and memory, and you're able to kind of batter that with load and kind of see what happens when you hit it with a bunch of requests and scenarios. And what tends to happen as a result of that is that you find constraints in the system. So maybe it's that you don't have enough versions of the application running. You need to increase it. Maybe you're trying to like load balance and that's not quite optimized. It's not able to ramp in an effective rate. And maybe there's other issues that you're not even able to debug and it causes you weeks of pain, but at least you've not got those weeks of pain just after you've gone live. So in this example, it's the replicas. So we see that the performance tests failed, needed to increase the number of versions of the app that we're running. And so we increase it in prod as well, because those two environments have got to mirror each other. So yeah, when it comes to performance tests, there's lots of different types. So you've got kind of down here, you've got the test length and then the maximum number of peak users on the left. So way down on the bottom left, you've got smoke tests. So this is a test that you run with a minimum subset of users, very short, very basic. And the idea here is that if that fails, there's no sense running a more complicated, longer test because you've already proved that it can't work. So why would you bother? A load test, by comparison, is you're trying to run the application at kind of the minimum and maximum that you're expecting users to kind of come through. And that might be based off analytics. It might be based off some agreements that you've got with your clients. But yeah, that's kind of the level that you're trying to run it at with a load test. And then the really fun ones at the top are your stress tests and your spike tests. And the idea there is that you're really pushing your system to the limit and actually past the system limit to see when it fails and kind of how it breaks down. The idea there is that if you have Black Friday and you get a sudden spike of traffic to your site, you want to make sure that it's actually either going to survive that impact or it's going to recover quickly. And so it's kind of moving this testing left so you don't see this issues on launch day. Okay, so I want to talk about K6 specifically. There's a bunch of tools out there, but I really like K6 because I'm a JavaScript developer and it's scriptable in JavaScript, which makes it really, really easy to kind of use, to control. And I think that like the learning curve for it, at least I found, is really, really easy to get to grips with, especially when you're trying to integrate it into a stack that might have JavaScript on the front and back end already. It's kind of a great place to sink your teeth into it. So yeah, it can handle all the performance tests we've talked about before in the previous slides. It's scriptable in JavaScript for ease, so you can't use all of the native APIs in JavaScript because it's actually written in Go, but through HTTP requests, you can require in modules which pretty closely emulate a lot of the native APIs. So yeah, it will look very familiar to you if you've ever touched JavaScript. So what does it look like? So under the hoods, effectively, it's a bunch of loops. So you have this concept of a VU or a virtual user, and the K6 engine is going to spin up a lot of these virtual users, which are going to concurrently hit your site and say, right, I want you to run this scenario. And then once you complete, I want you to run again and run again and run again until you reach a set number of requests or until a time frame elapses. Then it collects metrics about how that request happened. So how long did it take, the latency, the response that you got back from that, and then the timing of certain parts of that request chain. Takes those metrics, puts them in a report, and also pipes them out to a stream, which means that if you use AWS CloudWatch, InfluxDB, Prometheus, Datadog, the list goes on, there's loads and loads of integrations that you can use for this tool out of the box. And I just wanted to briefly go into kind of benchmarks, because a lot of the time people worry that with performance tests, you're going to have loads and loads of test runners all battering a site, and you're going to have to distribute that load over kind of a Kubernetes cluster or something ridiculous in order to actually generate that traffic. And whilst that's still true for some actually really, really high throughput systems where you're trying to test like 2 million requests a second or something, on a single service, you can actually run up to about 40,000 virtual users or 300 requests a second for a really basic test, which is about 1.5 megs for virtual user. So sitting quite happily in the middle when you compare it to kind of the memory usage of other performance testing tools. And this is what a basic test looks like in K6. So I told you it was simple. Effectively at the bottom down here, you've got a function, and that's the function that's going to run again and again and again until you say I'm out of time. And at the top, you've got an options object there, and that's saying the number of virtual users that I want to run and the length of the test. So this is pretty much as simple as you can get it. But yeah, that's sort of out of the box what you're looking at running a very, very simple test. And scripting in K6, so you're able to actually emulate loads. So in the example used before, we'd be able to show a ramp up to a certain number of virtual users, ramping up again until you hit your peak amount of traffic, and then tapering off for kind of a recovery stage, using the stages option as well. So that's really versatile and useful. And this is kind of the output that you get. So it looks like a lot of text. Please don't try and take that all in. We'll kind of break it down in a minute. But the most important thing is that it's looking at that request that you sent to your server, breaking it down into smaller chunks, and then kind of reporting on things such as the kind of the average, the min, medium, max, and then percentiles. So how many requests were under kind of like 99% of this value. So yeah, just to break those down a little bit more. So these are kind of like the connection metrics. So the amount of time is spent waiting for a connection to your service. the amount of time it's spent establishing that connection, and then the amount of time it's spent doing a TLS handshake as well, which is kind of like proving your your identity and generating some keys. And then your post-connection metrics, which are like, this is the bit that you tend to care more about, which is the time spent sending the data to the service, what it does when it's kind of using that data. So whether that's fulfilling an API request right into a database, calling a third party, that's your HTTP request waiting. And then you've got your HTTP request receiving, which is the time it takes to actually come back to you. And it aggregates that into a metric called a HTTP request duration. And that is the whole length of time that it's taken to actually kind of make that request and come back, so the round trip, if you like. So why is that useful? Why do we care about these figures? And for that, we kind of need to take a bit of a step back and think about, well, what are we trying to prove here? And in software development, there's this concept of a service level objective, which are effectively metrics that the team uses in order to say our site is kind of reliably up as far as we're concerned, compared to either other systems that we've got in the estate or analytics that we've seen before, or an agreement that we have with the client. So in this example, we've got like 99% of requests should finish within 5 seconds. Sorry, 99, and then 95% of requests should finish within 1 second. And then that should always be true when there's 100 users using the system in that kind of example. Then you also have service level indicators, which are kind of a measure of some aspect of the level of service that's provided. So that's your kind of things that tell you about your objectives. So your latency, error rate, and stuff like uptime. So yeah, bringing that back to K6, so why is it useful that we get those metrics? Well, what it actually allows you to do is kind of codify your SLOs. So if you had those kind of objectives from before, which is less than 1% returns an error, you can codify that in what's called a threshold. So you say, for all these virtual users hitting this service, when they come back, I want 1%, less than 1% of those to fail, and then I'll consider that a pass. And then similarly, you're saying that I want 95% of all the requests that I make to be under a certain threshold of latency. So in this case, 250 milliseconds. And what you're proving here is that if that fails, then the test will fail and you won't be able to release your software into production, or you'll have to get an alert or something and go and look at why your system is not performing to your objectives that you've set within your engineering team. So it's really, really powerful way of kind of also like getting to a state where you can say, it's at the level we want it to be, or it's kind of dipped below the level that we want it to be. In the bottom there, you can see that for these kind of fake SLOs, I've come up with the 95th percentile there has actually failed. So you're saying that it's taken 340 milliseconds. So 95% of requests are under that amount. But we've said, actually, it needs to be under 250. So it's a big red X and the pipeline has failed. So you'd have to go and have a look at that. So yeah, there's also this concept of something called a check, and checks are kind of slightly more functional. They allow you to dig a little bit more into the response that's come back from the API. So if you had a check that in this case was to say that the status is 200, so it's saying that like, I want to check that the status that I'm getting back from each request is this, and then you can also combine that with thresholds to say that I need the rate of those checks to be like above 90%, and if more than 10% of that statement fails, then again, fail the pipeline. So if anyone's familiar with testing libraries like Jest or JUnit or anything like that, that's kind of similar to an assertion. The difference being that the pipeline won't fail if that bit fails. So yeah. So moving on, so scenarios and executors, you have got lots of different ways that you can run K6, so different configurations that you can run it in. So these are called scenarios, and then the kind of the mode that you're running the piece of software in is called an executor. So this is a little bit of a different way of running it. So instead of just saying that I want each user to kind of cycle over again and again and again until we run out of time, this time we're saying that I want, say, 10,000 requests, and I don't care how the users get there, but I need them to be able to get to that kind of figure. And again, I don't care how long it takes, just I want 10,000 requests, please, on my service. You can also run it per VU. So you can say that I've got 10 VUs, 10 virtual users. I need each of them to perform a set number. So each of them needs to perform 1,000, and then I'll end the test. So that's another mode you can run it in. Constant arrival rate. So I found this kind of really useful, and the next one on the screen as well. So this is you're saying that I need there at any one time to be X virtual users hitting my service. So like there's like 100 virtual users. I need that figure consistently to be hitting this service. And you can increase and decrease the number of virtual users automatically to make sure that rate is maintained. So that's really useful for your SLOs where you're saying, I need there to be 100 users on this at any one time. And then similarly, you can ramp that figure. So again, if you were trying to emulate your real life traffic and kind of that cycle, then you could do separate stages. So you could say that I want there to be 200 virtual users for a minute, and then scale that up to 400 for 4 minutes, and then go back down to 0. So yeah, it's really versatile, especially if you're trying to kind of emulate what you're seeing in real life and trying to prove to yourselves, to your team, to your stakeholders that yeah, the system is ready to go into prod. Just to answer Joe's question in the chat, so you can collect it straight into Prometheus. There's a native adapter which will run. So if you were running a long time like smoke test, soak test, and you wanted to aggregate those into Prometheus, then there's a outstream which will go directly into that. So yeah, you don't have to write that yourself. It's kind of all there for you. Yeah, so I just wanted to talk briefly about automated performance testing. So that's great. We've shown how you might write those tests, but how do you actually get that? So it's part of your feedback loop, it's part of your development cycle, and it's kind of automated and all there for you. So just going back to this, you start wanting to think about, okay, well, I have a pipeline, I have developers, and they're going to get angry if I put a really, really expensive, long-running performance test in my pipeline. So you've got to start to consider about like the sorts of tests that you might want to run every time you merge code, every time you might want to do a release. And I think the answer, which I've kind of found in my research, is that when you merge to master and you want to make sure that there's kind of no regressions in your performance, you're sort of looking at these kind of smoke tests and load tests. So does it work under minimum load, and does it work under kind of the load that you'd see on a day-to-day kind of basis? So let's dig into those a little bit more. So as I say, a smoke test is running with like 1 or 2 virtual users for probably a maximum of like 2 minutes. All you're trying to really verify there is that it's not going to break when you hit it with no traffic at all, because again, what's the point in running it under high load if it's going to fail under low load? There's just no point doing that at all. And then your load testing is a little bit more interesting. So again, you're going to kind of have ramping cycles to make sure that what you're doing is you're emulating what you might see on a typical day. So say that you had a service level objective where you had to hit 100 users, and that's the maximum that the site is ever going to support in kind of a normal day. Then you're going to make sure that that is what you're hitting in your load test, and making sure that it can always support and pass those checks and thresholds whenever that's in prod. Okay, so again, we're going to go back to kind of a completely fake example, but just imagine that there's an app that you've been asked to create. So I like running, so I always use it in my demos when I give talks. So just entertain me with this one. But say that it's a bit like Strava. So you want to create an app where you can sign up, you can sign in, you can post a new race that you've done and kind of the pace you've done it at, and you can get those races back so you can view them on your screen. So you might agree with your client or within your team that they need to be able to do all those functional requirements that we've kind of just outlined, but they're anticipating that they need 10 concurrent users going through the site for this process, and the system needs to be able to support this. Now that is a very low figure. The reason it's so low is because there's a little demo that follows this, and I only have like a small Heroku box, and I didn't want to. It just can't sustain very kind of high throughputs. So yeah, I think that's kind of to my point. You can't run a production site off a hobby Heroku. So yeah, it's quite interesting to kind of see how far that can go. But yeah, users should be able to sign in and post a new race in no more than 10 seconds is the requirement there. So codifying that into kind of SLOs, like what does that mean? So what we're saying is that like 99.9% of users must be able to sign in and view races even when there's 10 users using the site. 99 must take less than 10 seconds to sign up and post, and then 95 must take less than 8 seconds to sign up and post a race. And we put a little extra one in there, which is to just kind of for our sanity, 95% of all individual requests that we're making to our service should take no more than 1.5 seconds. So this is kind of the demo app that we've built here. So you push some code to GitHub, it runs a CI, it deploys your code into just one environment for the purposes of this test. It runs a little smoke test, and then it runs a load test to make sure that A, it works under minimum load, and then B, it works under kind of like increased load. And then it pipes that into InfluxDB, which is like a time series database. So it collects data as it comes in, and then it pipes that into Grafana so we can display some pretty visuals. So demo time, yeah, so Sod's law is that this is going to go wrong. Not only am I doing a demo, but I'm doing a demo over the internet. So this is, if it goes wrong, I apologize, I've got some backup slides, but we'll try our best. So hopefully you can see this screen. I've got a little smoke test that I've written in K6, and I'll try and blow up the font there. There you go. And you should be able to see that in this smoke test, I've got one virtual user. It's running for just about 15 seconds, just to check it all works. I'm checking that 0.999, which is 99.9% of my checks pass. And I'm saying that there's a group of API requests here, and I want them to pass within, so 99% within 10 seconds and 95% within 5 seconds here, which is slightly different to the 8. That's just a mistake here. But yeah, the important part here is that that group is able to execute, and the majority of people are doing it within those timeframes that we've agreed we're going to try and adhere to. So yeah, just digging into the scripts a little bit more. All I've got here is just creating a random email. I'm signing the user through my API. I'm getting them to sign in, and then I'm posting a race to an endpoint which is going to persist that to a database. I'm then going to go get those races, and then that's kind of trying to emulate as closely as possible how a user might actually go through this process. And then at the bottom, as we discussed, we've got these checks to say, right, we want to make sure that each of these, we're getting the exact status code that we'd expect. So as we'll talk about a little bit later, how browser automation and how you might want to incorporate that into your performance test. But for the moment, it's just kind of like an API route through the site. But the most important thing when you're writing these scenarios is that you want to try and get them so they're going to emulate how that user is actually interfacing with your site. Because if you don't do that, you know, what's the point in testing that you can hit like a health endpoint and get a 200 back? It's no value. What you want to try and be doing is emulating the user journey as closely as possible. And then on a load test, we've got, it's a bit similar to before, but what we're saying is that there's actually a ramping in this case. So we're going to say we're going to start at 0 virtual users, we're going to ramp up to 5, we're going to stay at 5 for a bit, go up to 10, and then go back down to 0. And then kind of the thresholds in the scenario that we're going to run will be exactly the same. So yeah, let's give it a go, see if it works. So over here, I'm just on Circle CI. So I've already pushed the code that we're going to run just for this test. And yeah, I'll just rerun the last run to see what happens. Okay, there we go. So we've set off our CI running. And what we should be able to see in here is it's just going to load up K6 and start running a little smoke test for us here. And whilst that's kind of loading, I'm going to bring you over to Grafana. So I've built this based off a really old version that they had. I've published it up to Grafana, so you should be able to use it yourself if you're interested. And the idea is that we're reporting on the number of users, requests per second, errors per second, and then those checks that we've just talked about. And then there's a heat map of kind of where the requests fall in terms of buckets. So are they taking a long time? Are they taking a short time? And kind of how many of each? So here we go. We've just moved on to the smoke test stage here. So flipping back over to our dashboards, these are going to auto update. Okay, and here we can start seeing some traffic coming through. So for this smoke test, you can see it's just running at one virtual user. It's really, really basic. It's just hitting it with 1 user per second, nothing too fancy. Okay, and now it's ramped onto the load test. So you can see that it's now starting to ramp up in terms of requests per second. And yeah, we won't wait here for the whole test to run, but you get the gist. So it's going to kind of run those tests and then put them to this dashboard and show me like how long they're taking, are there any errors, and kind of the checks over here. It's worth noting you can expose so many more metrics than this. You can write metrics yourself. So whatever your system you need to report on and kind of alert on, that's going to be, you'll be able to do it from here. So yeah, that's a really good question actually. So this is what K6 is reporting. So when it hits that application, it's making that request, it's getting a response back, and then it's reporting those metrics and kind of putting them out to the dashboard. So yeah, this isn't what the app is spitting out. This is what K6 is reporting when it's hitting that under load. So that's what you get whilst the test is running. But if we kind of pop along over here and we look at kind of the output, we can see that both tests have passed, which is super. We'd be able to go and deploy that to prod. So if you look at the smoke test and we look at the output here, you can see that, yeah, everything's good. We're all happy with how long it took. Really, really quite low in terms of request times for a HTTP request to a free Heroku dyno. So yeah, it's all good. Happy with that. And we'd be able to kind of promote that into a production or probably kind of like a pre-prod environment after this. So yeah, that should give you a bit of an idea of kind of how that works in a continuous integration pipeline. All that code is on GitHub. It's SJO Edwards if you want to have a look, and you can pull that down. There's a local Docker Compose kind of version of it working as well. So you want to play about with it and kind of give feedback, put PRs up, whatever, go nuts. So yeah, just kind of keep going on this then, like what are some hints and tips of kind of running this in CI? And this is kind of holistic. It's not just specific to K6, but kind of most performance testing frameworks you can apply this to as well. So the first thing, as I've kind of said, is make your tests realistic. Journey based is better. You don't want to just prove that you can get a 200 back from APIs, but you might want to show that you can get like a response from one, you can pipe it into another request, and that at the end, everything is good. So groups tend to work better than kind of isolated APIs in that regard. And this is some advice that K6 give, which is to start small and build. So if you've only got time to start looking into this, you've got maybe a spike in your sprint, you've got a day, like focus on the things which are going to provide the most value. So if you've got an API and it needs to be really fast, then look at that first, get that regressed first, and then kind of increment on it. So some tests are better than no tests, which stands for most tests anyway, not just performance tests. And yeah, the other thing is that like SLOs are a really tricky beast. It's really hard to define what it means to be. How do we get to that magic number if this is the number of users that you mean? I've heard some people say that you take traffic you've seen before and double it. There's other people that say it has to be driven by metrics, and others it's driven by the agreements that you've kind of got with your customers. But yeah, the main point is that it's a collaboration. So don't assume just because you're the engineer writing the performance test, you know what that metric is. There's probably someone in the wider business that's going to be able to give you a bit more of an idea of what you're looking at there. And also there's some prior art on this sort of stuff. So if you truly don't know, There's quite a lot of guidance out there, some user testing about how long it takes people to respond to things. So if things come back in a tenth of a second, that's seen as instantaneous. If it takes a second, people are going to start thinking about another action. So they might, if your request is taking a long time, they might click on another tab or press the back key, etc. And if something's really slow, it takes more than 10 seconds, they need some feedback to say, look, this is taking a while, you can expect a response in kind of the next 10 seconds, etc. And also, we kind of touched on this, but just be really wary of that test cycle time. If you've got a performance test which is flaky and takes 40 minutes and is really expensive and everyone hates it, it's going to be a candidate for people skipping it and kind of saying, we'll move that to tech debt or whatever. Like, so really what you want for those long tests, and there is a place for them, those need to be kind of either running on a like a nightly cycle, for example, on a cron job, or running every release. So yeah, you just have a think about where it makes sense for those tests to run. It's very similar to kind of some functional integration tests that you might run as well. Yeah, really important one, make sure no one else is using the environment, because if you're trying to scale to a certain kind of throughput and someone else is firing it with requests or running some test scripts against it, your test is null and void. You've not really tested anything. You'll get false negatives and false positives all over the place. And as we said before as well, it needs to be scaled equivalent to prod. So if you're testing against a box which is bigger or smaller than your production environment, then that's going to be, you're basically, again, you'll get nothing, because the whole point is that you're trying to look at a kind of prod-like environment and work out how that looks. And the other thing is, yeah, make sure you don't batter your third parties. So if you're doing some really expensive performance testing and you've got a third party that charges per request, some people might be a little bit annoyed with that if you land a massive bill on their desk. So make sure you either mop them out, stub them out, or if it's really important that they're a part of a test, calculate that cost and make people aware. So yeah, I just wanted to give an honourable mention. We won't do any demos with these, but I just wanted to talk about them because these are really, really important. These two sorts of kind of extra performance tests once you've got a really good idea of what your load test for a normal day is going to be. And the first one is a stress test. So the idea with these is that they're not the longest tests. They're normally between like 5 and 20 minutes odd. But the idea is that you start ramping the amount of traffic, ramping the amount of traffic, and then looking at your metrics to see when the system starts to degrade. And what you're going to find there is that's really where you're going to find your constraints in the application, and you can kind of get from this, well, this is the maximum that we're actually able to support, and you might decide that you need to scale up certain resources or look at constraints or race conditions as a result of this. So yeah, this is quite interesting. I tried it against my local machine, and it sounded like my laptop was about to take off, but the output was really quite interesting. So running the same scenarios we've just seen before, and again, there's an example of this in the GitHub repo. You can see that my kind of 90% of my requests were taking a minute, which is kind of crazy when you think about it. So yeah, and all the checks failed. And this is what we got on the output. So you can see the heat map down here. We had a bucket. So red means really like lots and lots of users in that bucket. So at the real peak of the test, you can see that most users were taking a really, really long time. And if you think about how that affects the user, what they're seeing on the screen, probably a loading spinner or an error, you know, so it's just a really crap user experience when that happens. So for us, like our app starts to degrade really when we start ramping up the traffic to any considerable degree. So yeah, really quite interesting to start looking at this as well. And then the other one is spike testing. So this is meant to kind of emulate traffic in events like Black Friday. So you have a really, really sharp peak of traffic and then it goes away. And then what you're looking at is ideally your system's going to scale. It's going to support that. Like if you've got elastic load balancing, it's going to work. It's going to ramp up. But more often, like it won't, and it will fail, and it will die. And what you want to do after that is just make sure that your recovery is sufficient, so that users can after that can start using the site, and there's not any lingering issues which are going to affect you. So yeah, these tend to be a bit longer, just because you want to see like the tail end of that to monitor how your application recovers, as well as how it handles the load when it's actually there. And cool, again, like just some example output of a really basic spike test I ran. It seemed to handle this a bit better, to be honest. That we still got like 40-second request duration there, like, but all the test paths, so like, you know, the checks and the response that we actually got back from the API was a lot better, which is good. But yeah, again, local machine, not a fantastic example of a production system, but I didn't want to rack up a huge AWS bill for a talk. So yeah. And again, you know, that's what you kind of get is you can see in the peak there, we had loads and loads of users which were kind of functioning at 1 minute of latency, and then that starts to taper away, but it's not instantaneous. Yeah. And yeah, last but not least, I wanted to give a really brief honorable mention to this plugin, which is called XK6 Browser. Now, I mentioned earlier in the talk that you can also play with the idea of using like a headless Chrome engine to actually function on a browser, on a page, to start actually interacting with the DOM, so that you'll test it even more like they would be a user using them. However, just consider with this plugin that means that you have to run an instance of Chromium with every virtual user that you're trying to hit your site with. So that's fine for maybe 3 or 4, but I think that after that, you're going to need a pretty chunky server in order to actually fulfill that. The other thing to mention is that this is very much in kind of development. It's not ready for prod yet, but if you're looking to contribute to open source, it's probably quite a good place to sink your teeth into. But yeah, I went into this talk thinking this was going to be like a really, really fleshed out topic, XK6 browser, but actually it's pretty junior in its development, which is interesting. That brings me to the end, really. So yeah, I want to say, you know, big thanks for hosting. This is not something that I do more kind of like day to day. This is something that I've really quite recently started looking into as like a gap in my knowledge. So yeah, hopefully if that's of some use and gives people kind of a good starting place if they wanted to take another look. So that's it. Yeah, thank you very much, everyone.
I think you've got a few questions in the chat and in the Q&A there, Sam, so I'll let you take them away.
Super, yeah. So Joe's earlier question, I kind of went for at the time, but effectively, yeah, there's lots and lots of kind of integrations and plugins. So real time, you can see that outstream. I did have some problems, but I was trying it with mine in like, you've got to then remember that your time series database needs to be scaled appropriately as well. Otherwise it can't ingest the data fast enough to actually output it. So yeah, just some extra considerations there. Link to the GitHubs in the chat. It's also on the screen right now, so if you want to just have a look at that, then yeah, please feel free. Spike testing equals site app killer, absolutely, yeah, it really was. As a dev, do you think dev and tester roles will merge into one eventually instead of 2 separate roles? I think that's a very hot topic. I think that really what you're tending to see now is that people really like either embedded QA in teams instead of like a separate team, because what that means is that you share that context, everyone's at the same stand-ups, everyone's at the same ceremonies, and so you feel in a bit more part of a cohesive team. I've worked in and I really like working in teams where there's no official QA kind of role or tester role, and that's just a hat that you wear, and there might be a champion or a couple of champions who help you and develop, but really you're writing the software. I see it as at least in some part, your responsibility to make sure that that's running well in production. Could you do UI testing rather than API? Yeah, so that's the XK6 plugin. The problem is it's just a bit more expensive. But if you had a traditional kind of server-side rendered application written in PHP or something like that, you could then easily go through that site in that way. So SQS, oh, I can't remember what that is. Very interesting. I will get back to you on that one if that's all right. Brilliant. And then any considerations when implementing this for microservices? Yeah, good question. So I think that when you've got this for microservices, I think normally you've got a single point of ingress again. So you're still directing K6 to like a single endpoint to say, right, this is the traffic I want you to hit. But what you might see is that your constraints then become apparent. So say that if you had like a single point of entry, like a gateway, and that wasn't scaled effectively, then it might show you that there's a constraint there. But yeah, no, it's a really interesting question. Yeah, I think with that one, like main consideration with the queue is like yeah, again, that's more of an implementation detail, right? Because if you're trying to, that's part of your application, you're not going to hit that service individually. You might hit the kind of listener for that service, or the ingress into that listener. And that's how you'll achieve kind of the load through there. So you want to consider it as a bit of like a black box. The idea is that you're using this as you would use your application. So you are a user for all intents and purposes, right? So yeah, if that's a part of your application, then you might identify it as a constraint. But the reality is that you want to choose the service, you want to use the service as if you were a user, and that means using the public interfaces, so like the endpoints, etc. I'm just reading Hamid's there. Yeah, absolutely. So I think, so just to paraphrase that last comment, it's really hard to get people to buy into running these, like either on every commit or because people don't see these sorts of limitations or constraints until they happen. And so you're sat there going, well, the test pass or fails, I don't really care, like the code still works. But actually, you've got to place yourself in from the perspective of a user on day one. Like you could have written the most amazing, like performant code in the world, but if all you're going to show your user is a spinner, you've kind of failed your job, right? I mean, you're there to provide a service, and if they can't do what you've made your application, you set your application out to do, you've not fulfilled those criteria. So yeah, definitely everyone's responsibility to make sure this works. Cool. Any other questions? Either fire them in, or just hit me up on Twitter or Instagram. I don't really use Instagram. LinkedIn or GitHub. Yeah, go for it.
Oh, that's brilliant. Thank you so much, Sam. I'll give everybody a second just in case I have any sort of last minute questions. It sounds like everybody really enjoyed it and it was really great. Always makes me a bit nervous when I see a demo happening, but it looked like it went really great. So it's massive well done, and thank you so much for taking part as well. What I'll do, everybody, is, so this record obviously is being recorded. I'll send around tomorrow the recording if anybody wants to look back at anything that Sam showed us this evening, as well as some of Sam's contact details, if you don't mind.
It's fine.
Just in case anybody has any sort of questions that they've thought of sort of after this talk. So thank you so much. It's been an absolute pleasure having you, and I think we're hoping to sort of get you up to Newcastle at some point, aren't we? Get you up here for actual in-person meetup, which will be absolutely amazing. Can't wait. Well, hopefully can't wait. Maybe sort of September, October time. So that'll be great.
Yeah, it's super. Like I think that'll be really good. I think getting the feedback of doing talks in person is definitely, the pre-COVID way of doing things is definitely better. So yeah, for sure.
Absolutely can't wait. It'll be Sophie's first one you've attended in person as well. So we'll get organised. So anybody in here who's up in the northeast, you can look forward to that announcement sort of over the next, hopefully, sort of couple of weeks. But I'll let everybody get off and enjoy some of the nice weather as well. So once again, thank you so much, Sam. It's been an absolute pleasure, and look forward to working with you again in the future.
Awesome. Thanks, everyone. Cheers.
Thanks so much, everyone. Bye.